Hey, I hope I'm perfectly audible. Uh, just check the audio, please, and someone please let me know that the audio is fine because that's the only thing that's bugging me today. Is it okay? Like, is it not that bad? Like, there maybe a little bit uh, rush, but that you shall avoid. Hey, good evening, Deepika. But do you find the audio like clear about it? It's fine. It's fine. And the voice and the face they are in sync. It's not like the voice is coming later in my. Not like that. Yeah. What do you say? Perfectly fine. No lag, nothing else. Superb. Hey, that's a very good thing to know. I'll just start in like 1 minute. Just wait for 1 minute. Let's see if uh, anyone joins. This is the second session on permutation and combination. And yeah, so fine. Let's move to this part. Okay, so we have already covered permutation in the last week, correct? Last to last Sunday, and we have also understood like what's factorial notation is and how we can solve problems based on some simple arrangement of things, correct? So combination is considered to be an extension for that part. So if you know permutation, understanding combination is easier or simpler. Okay. Also, you have to remember the factorial notation. So I'm just recalling something from this place that n factorial is, so it is simply like n times n minus 1 times n minus 2 times and so on till you reach 1. Correct. This is what we remembered from n factorial. The other thing that we also remember is from the permutation symbol, which is nothing but NPR, where you are selecting, so arranging r things out, arranging r out of n things. Okay, so this is like n minus r factorial. Correct. We gone through the code question where we said that okay, let's say I give you two places and I say there are three values that you can fill in these two places, and let's say repetition is allowed. So when you say the repetition is allowed, so if repetition is allowed, then what you do, you can say that both the places can be filled in three ways and it's not stopping us, correct? So in that case, what we call it like just 3 times 3, which is 9. Okay, so there will be total 9 ways to do that because repetition is allowed. Okay, but what if the repetition is not allowed? So if repetition is not allowed, repetition is not allowed, then in that case I know that the first place can be filled in three different ways and the second place can be filled in two different ways. So there are a total 6 ways to fill that. So what I'm going to do, I'm just going to write those 6 ways so that it is fine. So the first I can say ABC, the second I can say ACB, this I can say BAC or BCA, then CAB and CBA. Correct. I'm just extending it now and leading towards combination. I will take one more example to like clearly explain this, but for time being, let us say that. Yeah, so I'm taking the case for 3 and so I have got two places to be filled and there are three things I can select from. The, um oh sorry, what I did, my mistake. I just forgot it. I'm sorry. I need to fill two places. I just realized now. I took the example of a two place thing. Sorry for that. So the first thing, I can get a code AB or I can get a code AC. I can get a code BA or I can get a code BC. I can get a code CA or I can get a code CB. Correct. So what we yeah, Deepika, I corrected it. So what we have to understand that these are the only 6 ways. Obviously repetition is not allowed, so you can't repeat something again. So this implies now that the arrangement does, the order does matter, correct? So for me, AB is a different code than BA. Okay, So let's say I take up and match AB and BA. So I say they are not equal because arrangement matters. Same way I can say that AC and CA are not same. They are different code. Okay. And in the same order I can say that BC and CB are different code. That is only when we talk about permutation. Okay, when we talk about permutation. But if I would have said what is the total number of, only you are only saying ki I just want to get like the arrangement, the order doesn't matter. The order doesn't matter. Even if it is AB or BA, it is same for me. So in that case, these two will not be written two times, of course. So obviously this will imply that now these code will be written in the form of either AB or a BC or a AC. So there are only three combinations, not the permutation. I hope you understand. This is where combination pops up. So in combination, the order doesn't matter. Even it is AB or BA, it is the same for in case of combination. But in case of permutation, the order does matter. Now, do you remember that this could have been written in the previous example case or the formula 3P2? You are filling two things and you have got three things to select from. So now you say that, or two places, whatever you call it. So 3P2. Now we know that this, as per the formula, should be 3 factorial divided by 3 minus 2 factorial. Correct. Now in this case, you notice that I'm I'm actually dividing this value. So if you simplify this value, this is 6. I hope this is from the last class you remember. Okay. This is just 3 factorial, which is 6, because the denominator is 1 factorial. Now we know that there are 6, but out of 6 the repetition has happened 2 times, or basically you think like this: how many ways they can be arranged in themselves. So you listen to this, okay? This is the most important point. I'm connecting the permutation with the combination. I'm saying that two different ways can be arranged in itself. How many ways? 2 factorial ways. Correct. So I can arrange two different places with two different things in 2 factorial ways. Correct. So I will divide it by 2 factorial. Now it will obviously give me the answer as 3. I'm going to extend the same thing concept to like a higher level. So let us increase the number of values and try to understand it much better. Let's say we have got A, B, C, D, 4 different letters to select from, and we have to make up a code of three letters. Okay. Now these 3 letters, now I'm trying to fill it. For a few I will do it so that you can understand, and then I will not make it for every other, but I hope you'll get the idea. This is the only thing I want to get you the idea from. So now you see this is A, B, D. Now this is done. BC is done. BD done. So let us talk about CB, and same way we can talk about CD. Then we can talk about DB, and then we can talk about DC. So notice that for each this A, carefully understand this, for each this A, there will be these combinations of BC, BD, CB and CA. So there will be 6 total of them. Correct. So this will be total 6 ways. Correct. Now you understand the next thing. Okay. Now these 6 ways I can also go up and say this is true for all with the letter starting B. Correct. There will be again 6 ways. So this simply implies that if I go like this, I can have a C starting, okay, and I can have a D starting. So total there will be 6, 6, 6 4 times, basically 24. Now this is the most stupid way of solving it. Okay, the reason being because this is too much, like this is not like a proper way to get the answer, but this is a proper way to understand the combination. Okay, because I will come back to it. I know that the easiest way to permutate 3 different places, like 4 different things in 3 different places, is just simple 4p3. Correct. Arranging NPR, you know that. Correct. Now this simply implies that I can write it as 4 factorial by 4 minus 3 factorial. Now this is simply 4 factorial because the denominator is 1 factorial. So what you get is a 24 value. Okay, I'll just bring it to the right hand, to my left, sorry. Okay. Now, you know that This 24 ways are the total number of arranging things where order does matter. Because for me, ABC is different from BCA. Correct. But what if the order doesn't matter? Then of course this ABC, now this will be first, let it be BAC, and the next let be BAD, then next let be BC, no, yeah, BCD, and or BCA, whatever you call it, and BCD. Okay, now you understand this point. Now BCA and BCD, if you notice BCA and ABC, they are actually the same thing in case of combination. So these things will start to repeat. But understand one simple thing. What I got it already. I got 24 ways already. I know I have a 3 scenario things. So consider that as a group. How many ways can you arrange these 3 things in 3 different places? 3p3 or 3 factorial ways. Correct? 3 things in 3 different places. How many ways you can arrange that? 3 factorial ways. So you have to divide that extra 3 factorial. That because those are just coming repeatedly, like ABC, BCA, CAB, like that, they are revolving around it. Correct. So this simply implies that you get 24 by 6, which is nothing but only 4 unique ways of selecting. Okay, so there will be 4, like if the order doesn't matter, there will be 4. Okay, I'm now going to like bring it back again after like 3 or 4 slides or questions, whatever you call it. So let me move to the next one. Okay, let us take a very simple question. I will bring back and connect it later, not now. Okay, so understand this. How many ways are there to arrange 3 chocolate cookies, and 10 butter cookies in a row of 13 cookies? Now, this is a very simple case. You have got 13 cookies to be filled. Correct. So, how many ways you can arrange 3 chocolate cookies? Okay. So, if you have got the answer, it's very good. See, listen this. 3 chocolate cookies. So, 3 chocolate cookies. So, there are only 3 chocolate cookies. Correct. And 10 butter cookies. So this total will be filled 13 only. Yes. So can you tell me the answer? So let me see if anyone can get me the answer. Then it would be great. Can you think of it? See. Okay, let us think about like this, Deepika. We are saying that there are you have to arrange 3 chocolate cookies and 10 butter cookies into a row of 13 cookies. So if let us denote these chocolate cookies by say CK. Okay, chocolate cookies, and the butter cookies by BK. Okay, or B or C, simply let us say this. Not let us remove this K and all. Okay, so the first case is arranging 3 chocolate cookies. Now obviously this can be C C C, yeah, and B B B and so on. Correct. Or it can be C B C B C B, like that way. But you are restricted by the number of B's. So if you notice, it's just 13 places. So the first place 3C3, and the next place is, so so you are selecting 3 chocolate cookies, and you have to select all 3 sub chocolate cookies, and then you have to select 10 what 10 butter cookies. So again you are selecting 10 butter cookies. So 10C, oh, so 10C10. You get it? Can you simplify and tell me the answer here? If you solve 3C3, because you have to select 3 chocolate cookies, correct, and then you have to select 13 10 out of 10, because you have to select everything, because you can't change it. So out of 3 things you have to select 3 things, because you have to fill it completely 13. You can't fill it. If it was less, then it would have been different. So think like this. Okay, so out of 3 chocolate cookies you have to select 3 chocolate cookies. Out of 10 butter cookies you have to select 10 butter cookies. There is no other way. Correct. So what is 3C3? First you have to think like this. What is 3C3? You know that it is simply, okay, I didn't do it Oh, I have to come back. This question will be trouble for me. I'll come back to when I will teach you the formula, this NCR, okay? Otherwise, it will be a wrong way of me teaching that. So I'll come back to this, okay? I'll come back to this once I teach you the formula. That NCK is n factorial by n minus r factorial times r factorial. Let me teach you that. No issues. I shouldn't have put this question here. I think so now. Okay. So understand that in combination, what happens? You are just selecting, arranging things without considering the order. This is what I wanted to teach you there in the last question. You are just selecting the things without considering the order. So it doesn't matter in the last question if I get which cookie or like which ordered cookie. I don't worry about it. I have to get the one cookie like one, like I have to get chocolate cookies and butter cookies. Chocolate cookies and butter cookies. I have no problem whether I get it first chocolate cookie and then butter cookie. It doesn't matter at all. The positioning doesn't matter at all. Okay, that's why it was a combination question and I couldn't simplify it because I didn't tell you the formula. So I have to come back to that, but that I'll explain it again. Okay, now let me just explain this next part, which is this thing. So this thing will help you to understand that thing, like in this way. Let's say there are 10 people and we say that we can have a 10 factorial ways to line up. Correct, which is the correct thing, because if I say that the 10 peoples have to be arranged in another line, so first place can be filled in 10 ways, the other place can be filled in 9 ways, then 8 ways, then 7 ways, then 6 ways, and so on. Correct. Now, but there is only one way for the 10 people to form an unordered group. Yes. So we say that 10p10 is 10 factorial. Listen carefully. This is what I want to explain in that question. Again, I'll go back. If I have got 10 people, if I have to properly say, okay, Aman should follow, Deepika should follow, Mansi should follow, Ravi should follow, like that. And also, I will say, no, not Aman, then Ravi, then Deepika, like that. So in that case, the order is important, and we then say we are using permutation. So we write 10 factorial, which is nothing but 10p10 also. Correct. But selecting everything is what? There is only one way. Do you get this point? What I'm trying to tell you now? There is only one single way of selecting everything. There is no other way. Because it doesn't matter if I get Aman, Deepika or Ravi, or I get Aman, Ravi and Deepika. So 10C10, that is just the selection. The order doesn't matter. The order does not matter. Is just one unique way. I hope this is clear. And by the way, my chart is not moving or what? Let me just refresh it. Deepika, can you type something? I can't see any messages popping up. So if you're replying, yeah, it's popping. Oh, thank you. So can you now tell me what will be the value of 100C100? It's like you're selecting 100 things and you're arranging them in 100 places. Just the selection. You get this word clear. The order isn't not matter at all. Correct. That will be just one way. That will be just one way. So can we just go back and, oh wait, I'm pressing wrong buttons today. Can we just go back and tell now? Now I'm back. What will be 3C3? So I have to select the 3 chocolate cookies. There is no other way. I have to select all the 3 cookies. I have to fill them in 3 places. It doesn't matter where I fill it. It's just one way. You get it? Again, I have to select 10 chocolate, 10 butter cookies. Sorry. It doesn't matter. Wherever I put it, they are all butter cookies. I have to just get it. So one way. So this is one unique way. Okay, because being a chocolate cookie here or there doesn't matter at all for this point. Okay, if you are just, the order is not mattering, the order doesn't matter at that duration. Okay, that duration. I hope this is particularly clear. The order is totally unimportant. Okay, let's come back. That question should have been after this. That was the only trouble. So here you have to understand this thing. So till now, do you remember what I was doing? I was telling you, hey, you know that there is a 4 things like the A, B, C, D. Hey, I have to fill it in 3 places, arrange in 3 places and all. So if I do the combination, it is just 4 factorial, because 4 factorial, you understand. For permutation, it will be 4p3, which is 4 factorial, divided by what? The final value, it is 3 factorial, because they themselves can be arranged in 3 factorials, which is the extra count I have added, and the order doesn't matter. So I've added the extra count. This actually simplifies to this way. Let us not consider k1, It's just for the theory part, copy pasted content. Let us say NCR. Now we know that NPR is n factorial divided by n minus r factorial. But when we are saying that in NCR, the order doesn't matter. The order doesn't matter. So it's like I have to get rid of this extra R arrangement of things in R selected places, which is the R factorial. So some you can write like this. You can remember like this. Okay, it doesn't matter where you write the R factorial. That extra R factorial, always you see this was what 4p3 divided by 3 factorial. Correct? And 4p3 was 4 factorial. But 4p3 again is what? It is 4 factorial divided by 4 minus 3 factorial, and 3 factorial was extra. You get it now? I hope this is clear now. That extra arrangement of things which is counted in permutation has to get removed from the when you're talking about combination, and that's why you remove that extra. How many places they can arrange themselves? 3 factorial ways. So they have to remove that extra 3 factorial, that extra r factorial, because there were r places. Correct? R places. That's what the word is. R places. Okay. I hope this is clear now, and let us come back to the next one. Oh, this is a very simple question. Don't worry about the big numbers and all. It's basically just telling us to use this number somehow, the formula that we have studied. Okay. So we know that there are these many ways to permute 7 items from a set, 9 items. So when you are arranging in how many places? 7 places. Permute is happening in how much items of permutation is happening? 7 items. From what pool? From 9 items pool. So basically this is 9p7. If you go on and if you simplify it, it will still be 9p7. You get it? So 9p7 is what? 181440. It has to be the same thing. And then it is saying there are 504 ways to permute 7 items on their own. Now you get it? Now in itself, how many times the 7 items can permute, can arrange in itself? 7 factorial ways. Correct. We know that 7 factorial ways they can arrange themselves. The ABC was arranging in 3 factorial among themselves. Correct. So 7 factorial ways. So this implies that 7 factorial is given as 5040. They've given you the values. They're asking you what is 9c7. So we now understand that 9c7 is nothing but 9p7 divided by extra 7 factorial. Do you get it? So the final answer is just 181440 and 5040. So if it simplifies, just simplify it. Like how much lowest fraction you can reach, and then you can stop it. Okay. Maybe if it is perfectly divisible, I'm not sure, but you can check it later on. I hope this is clear now. I hope this question also makes it perfectly clear now. This extra 5040 ways, because they are rearranging themselves and we just have to count them one. Okay, just we have to count them one. Why I'm focusing it? Because that's the only trouble every student has. Difference between permutation and combination. They always get troubled. Okay, let's do the next question. Now there are only problems except for one extra information. Okay, that will be helpful to you in class 12, but not now. Okay, two committee co-chairs in 11th. Two committee co-chairs are selected from 10% committee. Okay, so I have to make a 2% committee. I have to make it a 2% committee from a 10% committee. So there is a 10% committee already there. I have to make 2% committee. So does it matter if I take Aman and Deepika or Aman and Ravi and Raman and Ravi? Like from this way, let's remove this one. I have to create another example. So Aman and Ravi or Raman and Ravi? Raman. Ravi and Aman. Tongue twister happened. Aman and Ravi. Ravi and Aman. Not Raman. So doesn't matter. They are still two people. They are the same committee. The committee is not going to change its stand okay, these are two different people just based on arrangement. So that's why we do a combination. Have you realized the importance? Have you got the clue when you do the combination? That's where the major problem is. We never get to sure whether it is a permutation or a combination. Do you now get it? It is a combination, because the order will not matter, and therefore you have to just do a 10c2, because you just have to arrange two things out of 10 different things. This is select basically. It's like a selection. The order doesn't matter. So now this is still that's called arrangement. That's why the trouble is, because the word arrangement comes, people think it is permutation. It's not always like that. If the arrangement has no importance on the order, it is combination. If the arrangement has dependency on the order, then it is permutation. That's what the major difference is. Okay, so this is just simple 10 factorial divided by 2 factorial, 10 minus 2 factorial. I have to teach you something extra. Just wait for it. I'll teach you a lot of things. Don't worry. So this is 2 times 8 factorial. Now obviously because 2 factorial is 2, I hope you are still following. The formula is NCR is n factorial divided by r factorial times n minus r factorial. Okay, so this will give us 10 times 9 times 8 factorial. This comes from the session 1 where we have already covered this concept that we should not expand it further. I already taught you that. Hope you remember that. And this gives us a simple answer of 45. Yeah, Deepika, you are correct. Superb. Next one. Okay. So Lucas has 8 classes to choose from and needs to take exactly 4. Okay, so he has given an option of 8 classes or 8 subjects, whatever you call it, and then he has to just select exactly 4, just the 4. How many different selection of classes can Lucas choose to take? How many different selection of classes can Lucas choose to take? Consider this. It's like he has to just get 4. Simple. Out of 8. So 8C4. Because it doesn't matter whether he goes to the class 1 first or the class 2 first. It is totally unimportant for him. It is math, physics, chemistry, bio. He's selecting these 4 classes. So he's leaving maybe English, economics and computer and Hindi. So it doesn't matter if he selects first the math and then physics, or first physics then math. It is the selection. Therefore 8C4, which is very simple, like 8 factorial divided by 4 factorial times 8 minus 4 factorial. Here basically this is 8 factorial, 4 factorial by 4 factorial, leaving the answer for you, waiting for the answer to pop up on my chat window so that I can just simply write it. Thank you, Deepika. I hope it is correct, which is generally you are. So I'm considering this is the final answer. 70. 8765, 4, 24 and 2, 70. Correct. It is correct. 35 times 2 will come and it is 70. Okay. Okay. Let us now just prove this simple, very important. Though it is a very simple equation or an expression, it's the most very important concept to simplify, like the next set of problems. Is it always true that selecting one things out of n things is same as selecting n minus 1 things out of n things? Think like this. Will it matter if I have been given 5 things, and let me just make it like that, and I have to select 3 things out of it? Is it not indirectly I am not selecting 2 things? Do you think like that? Can you think in the just negative statement? It's like the water is half filled or is it half empty? The glass of half glass of water, correct? The same way we think like this, correct? Is it half filled or is it half empty? It's like the similar situation. I am selecting 3 things out of 5 things. Arranging them, the order doesn't matter. That's why I'm using the word selection for like continuously now. But I'm deselecting 2 things out of 5 things. That's the same thing. Kind of. So basically, it's the same thing if I say 5C2 or 5C3. Because if I'm selecting 2 things, I'm leaving out 3 things. So indirectly, they are getting selected. They are getting selected. It's like I'm removing positive charge, so negative charge is getting like created at the same time to make the species neutral. Like that scenario you can remember. Okay, that analogy may be helpful. So this simply clarifies and we have to just prove it. So I'm not going to like prove it one by one. I'm just going to use a generic formula and prove it directly. So we know that this is the case. So let us talk about NC1. Okay, so this is n factorial divided by n. Sorry, I should write 1 factorial, though you know that it is n1 only. Okay, so what we get is n factorial, which is n times n minus 1 oh, stupid me. N minus 1 factorial. 1 factorial is 1, and this is n minus 1 factorial. This will get cancelled, so it is just n. Yeah, it is true. So this is true. Let us talk of the next one, NCn minus 1. So this is n factorial divided by n minus 1 factorial. I hope you all remember this. Last class we already did this thing. We already talked about that the brackets are very important when you write factorial notation. I hope you now understand that this will be n minus n getting cancelled. It becomes a 1 factorial, which is 1. So I'm not writing it again. It is n because this is a 1 factorial. So now you see both of the values are coming to be n, and that's the correct case. So it's very simple. NC1 is just simple n. Yes, it is. Yeah. So one place you have to, out of five you have to fill one place, so the answer is five. There are five ways. I can select A, B, C, D, E. There are five ways of selecting for just one thing out of five things. Yes, I have to select four things. Again, I'm deselecting one, so basically it's the same five ways only. You can go ahead and find it. Okay, let's go to the next one. What would factorial for a negative number be? No, factorial is not defined for a negative number, Deepika, because factorial is basically selecting things out of some things, kind of, correct? It's like the arrangement of things. They can't be negative. So there is no minus in factorial. The last factorial you talk about is just 0 factorial, which is like not doing anything. It's still one way out of doing, not doing anything also. There is no minus of it. I am not aware of it. Maybe if it is, but for my knowledge so far, I haven't seen, and it can't be. Maybe in higher mathematics somewhere, maybe, but not here, not here. Okay, because negative factorial won't make us sense, won't make any sense. Okay, let's take up the next one. So a class has 30 students. Kerry wants to choose 5 students to do a project, and Arthur wants to choose 25 students to do a project. Does Kerry or Arthur have more choices? Now it's just a simple statement and a very stupid statement repeated now. We know that the Kerry will select in 30C5 ways. So this is the selection process for Kerry. In case of Arthur, the selection process will be he has to get 25. He has to select 25 out of 30. Now we know that, but NCR is same as NCN minus R. This is what should be coming from the last part. NC1 is NCN minus 1. So I should have generalized it. So you just write it somewhere that this will be the most useful relation, that NCR is same as NCN minus R. I hope you understand the point. Selecting that thing is just like deselecting the remaining things. That's the same way. Okay. So, or deselecting the same, whatever you call it. It's just the way you say it. So it is 30C25. The formula says that this can be written as 30 minus 25. So basically this is 30C5. That's the same value actually. I don't need to go and further simplify it. It's pretty obvious they are equal. Okay, let's take up the next one. Okay, the question is, okay, it's that written. Okay. How many ways are there to select 3 males and 2 females out of 7 males and 5 females? Now this is a little difficult. Exactly doing the same thing, okay? You have to just select it. You get the point. Like these places, 3 males, you have to get from 7 people, 7 males. So obviously these 3 I have to select from 7 people. So this can be done in 7C3 ways. Correct. Correct. I hope you get the point. Okay. And then I have to get 2 females. So I have to get 2 females out of how many? 5. So it can be done in 5C2 ways. But I'm still doing the, like the total 5 people. So what I will do, I'll say this is the multiplication. 7C3 ways, because they can be selected in 7C3 ways, they can be selected in 2C ways. So total multiplication, you just use the multiplication rule here. I haven't elaborated it much. Maybe some other class if you people want me to, because this will be like beyond simpler things and I have to go and take up more example to simplify this thing. Not in this class, but maybe in the next class. So simplify this. Okay, I tell you a trick. You people know that 7C3 is just simple 7 factorial by 3 factorial 4 factorial. Hope this is okay. You now can use directly. And this is 5 factorial divided by 2 factorial times 3 factorial. Just expand it to this maximum value. So 765, and I'm not writing it. So 3 times 2, and this is 5 times 4. 3 factorial will go away, and 2. So 6 will cancel this. So 2. So 35 times 10. So 350 ways. Okay. I hope it is clear. Okay. Let's do the next one. Can I teach you something here? Okay. I just want to extend this. Don't get overwhelmed or something. No, I should not. I have to bring up a lot of concepts here and it might trouble. So it's better I should avoid it. But you can bring up probability of like total selecting five things like from that how many people, it doesn't matter, then you can talk about it. So if that's your favorable, just I'm giving you this hint and leaving it. If consider that this is the favorable event, correct? This is my favorable event. I want this to happen. What are the total number of ways? Can you just give me this answer once? What are the total number of ways of getting five places of five people? Total five people, because indirectly you're getting total five people only. Out of how many total people? Total number of it. That's your favorable event. You want this to happen. This is like getting two heads. Correct. Out of all the three different situations of like eight different situations of head tail head, and so on. Correct. So getting two head. So that's like your favorable case. So same is this our favorable case. What is the total number of cases? The total number of cases. Can you think about it? What is the total number of people? 12. You get it? There are total number of 12 people. And you have to just arrange in 5. So these are the total 12C5. If you just divide this value by 12C5, you will get the probability of getting this thing. Something like that. I hope it is fine. Okay. So you get it. You are getting number. This is how probability will be corrected in future. Okay. I can't go and increase this level difficult. Maybe next class I'll arrange probability with this if you want. Do you want this to happen in the next class? Do you want me to correct now permutation and combination to probability? If you wish, I will do that. So at a party, this is the last question for today. Okay, this is the last question for today. At a party, everyone shook hands with everybody else. Now this question can be done using combination and even without using combination. Trust me, you can use just arithmetic progression. Okay, and you can solve it. Even not arithmetic progression, the sigma n series formula. You can use that and you can simplify this question. Or you can simplify this question using what? The combination. You know that not any person will get a handshake with himself. Pretty obvious, pretty simple, correct? So, I have to get two people to shake hands. Yes, that's what the point is. You have to get two people to shake hands. So, the shaking of hands, the total NC2 ways are there. Getting any two people and they will shake the hands. The order doesn't matter. It doesn't matter. So I am selecting lesser number. Permutation is not the correct thing. That's why not NP2. Because if Aman is shaking hands with Ravi and Ravi is shaking hands with Aman, they are the same thing. You get this point now in your mind. They are the same thing. So we are not talking of permutation. We are talking of combination, which is NC2. Correct? And we know that this number has to equal how many handshakes? 66. Indirectly. So let us solve this. N factorial by 2 factorial divided by n minus 2 factorial times 66. You know that n factorial is what? N times n minus 1 times n minus 2 factorial. I hope you all remember this. I started the class with this line itself. And have explained this already in the last class. So those who are the first time watcher can watch it. Okay. Now, you know that this can be cancelled. So this is n square minus n minus 132. If you are smart enough, you will find that 132 is actually a multiplication. It's a divisible by 11. And any number divisible by 11 is very easy to find because 11 is a prime number, no? So we can now just say this is 11 and 12. And we want the difference to be 1. Superb. So this is minus 12n plus 11n minus 132 is equal to 0. So take common n, you get n minus 12. Take common 11, you get n minus 12. I'm not teaching you quadratic and all those things. This is not the class to teach you a quadratic simplification. It's a simple quadratic equation and can't be negative, okay? Number of people can't be negative. So there were 12 people in that party. A very generic question. So in the initial stages, it was considered to be very difficult, but it is a very simple question. Okay, let's talk about alternate solution for this. Okay, I know that this person will shake how many, the first person can shake hands with how many people? Let us consider there are n people. Obviously, he can't shake hands with himself. So he will shake the hands with n minus 1 people. Correct? Now, once this person has shaken the hand, the next person can shake hands in only n minus 2. Correct? And so on till the last person will be just shaking hands with the one person, because there will be all will be consumed up. Correct? And this total will be the total number of handshakes. Now, consider this as a reverse series. Not like this way, okay? Consider it as a reverse series. 1 plus 2 plus and so on till n minus 1. So you are not adding till n, you are adding till n minus 1. Now what does this imply? It just simply implies this, that sigma n is n times n plus 1 by 2. I hope you all remember this series. If you have been taught out this, it's good. If you aren't, you can still use the arithmetic progression sum formula. Use that. The common difference is 1, the first term is 1. Okay. And there are n minus 1. So you can take up a plus an wala formula directly. Sn is equal to what? What is Sn? It is n by 2 a plus an. Correct. So it will be what? N by 2 a. What is the first term? But no, there are not n terms. There are how many terms? N minus 1 terms. Obviously, there will be n terms. Then this person would have shaken hands with himself. 1 plus last term, n minus 1. So you cancel this. What you get? N times n minus 1 by 2 is equal to 66. That's the same equation, beta. Exactly the same equation, correct? Which I just simplified. N times n minus 1 by 2, 66. Wait, can we just use this direct formula? Yes, we can. Why not? Because now I'm adding not n values, not n consecutive natural numbers from 1. I'm adding n minus 1 consecutive natural numbers. So in place of n, I will fill just n minus 1. So in place of n, I'm filling n minus 1 plus 1 divided by 2. I have done it like 3 different ways. Whatever way you want, you can do it. Basically, the second way has 2 parts. So again, you get the same equation. You get it? You use arithmetic progression sum formula? Good. You want to use direct sigma n formula? Good. You want to use combination because you have read about it? Super. You can use that. Okay. So I'm stopping here. Just not necessary to continue further. This was a lot of things. First, you have to start absorbing these things. And this was not for like a for full detailed permutation combination. That won't take just 2 classes. It will take at least 6 to 8 class. Okay. There are a lot of things that has to be taught. There are different conditions on permutation combination, at least 6 to 8 class. So we are stopping here as of now. I hope you have understood a lot of things and if you have enjoyed it. For those who are watching for the first time, there's a channel on Discord. So we have a very vibrant community now, and we are posting a lot of things there. So if you haven't been there, you can come up. So I always create a new channel here, and oh, I don't need it. There's already a channel called Permutation Combination. You can come up and you can ask questions here. You can discuss a lot of things. There are a lot of people here, and we have a daily challenges series where we take up a lot of different types of problem on different types of concepts, math and science, and like even economics will come up sooner or later. Okay, so hopefully you'll enjoy this thing, and hopefully you will be able to understand a lot of high level concepts if you are in lower grade, and you can, or maybe you'll be able to clarify a different concepts. So I'm stopping here. Good night to all of you. Okay, we'll see you in the next session then. Bye everyone. Welcome, Deepika.